Okay, good morning. Welcome to
FamilyMath397a.
Yeah, 397a. Today we're gonna talk about randomness and primes a little bit. So we've taken some dice and just arranged them totally randomly on our board, right?
Mm-hmm.
Completely random.
Yeah.
It's the most random thing that ever happened, right?
Yeah.
What seems to have happened to our dice?
Well, they're all threes.
Yeah. So what would you, if you saw a bunch of dice that were all threes, would you say random or not random?
Not random.
Not random. Okay. So we have these dice.
Yep.
And when we talk about dice, what sort of probability things can we talk about?
1/6 probabilities, because there is.
Well, it's like how many times on average will a dice roll? Like if you roll 2 dice, will at least one of them be like 5?
Ooh, that's actually a really interesting question. Okay, so you roll 2 dice.
Mm-hmm.
What's the probability that at least one of them has a 5?
Yeah.
Oh, great. How do we solve a problem like that? That's a great question.
I would do it in the cases where, with one of them being 5, you have, if exactly 1 is 5, you have 6 choices for what this one doesn't matter, but actually no. We need to put it into cases, so you have 5 choices for what this can be.
Uh-huh.
Because you don't want this in this situation.
Okay.
So there's 5 choices for what this die can be, and then you can do it the other way.
Okay.
And then there's this case.
All right.
So that would be 11 cases out of 36.
11 out of 36. That at least one's 5. Can you think of any other way to solve that problem?
So, what I would do is, so there's 36 total choices.
Uh-huh.
So they have to land on a 5.
Yeah.
So if we have a case where one lands a 5, so there's there's going to be 6 cases that this lands a 5. There's going to be 6 cases where this lands a 5 here.
Okay.
And then there's going to be another case where both of them land a 5. So that's 7 out of 36 so far.
Why is that new case different than one of the cases that you already had?
Actually, it's not different because we have 5, and you already rolled a 5 here.
Okay.
So, then we have cases where you didn't roll a 5 here, but you roll a 5 here.
Okay.
And that's going to be 5 new cases. It's going to be 5 new cases because you already used the 5/5 one.
Okay.
So that would be 11.
All right, good. That's good. That's very similar to how your brother did it, but that's good.
I also see a different way you could do it.
Oh, awesome.
Well, when you can count the ways when none of them are 5s.
Oh, okay. How does that happen?
Well,
Whoops. All right.
so you have 5 choices for what this die could end up being because you don't want a 5.
Okay.
And then you have 5 choices for what this die could be. And it ends up a 5.
Okay.
So then there'd be 25 cases where you have no 5s.
All right.
So it means there's 11 cases where you have 5s.
Great. Do you understand that?
Yeah,
You
it's
understand?
complementary kind of.
Yeah. So instead we count the opposite. So we say no 5s.
Yep.
Okay. Cool. Hey, that was a surprise little diversion and a great one. So now I'm going to move to what I planned to talk about in the first place.
Alright.